Hello everyone. Today I'm going to talk about chapter 11 gases. In this chapter, we are going to review some laws in the chemistry of gases. Then you'll learn how to solve the problems based on these laws. First, I'm going to remind you we have three states of matters in the chemistry: solid, liquid, and gas. And the definition we had for the gas is any substances with not definite shape and not definite volume. So we had this basic and fundamental definition: no definite shape, no definite volume for substances. Most of the substances that we are talking about you will find in our atmosphere, like oxygen gas, nitrogen gas, carbon dioxide gas. Whenever we talk about the gases, first you should know that most of the covalent compounds or most molecules considered as a gas. So if we are talking about ionic compounds, it means compounds composed of metals and non-metals. They are, in general, mostly they are solid. But for the gases, when we talk about the molecules and, in other words, covalent compounds, only non-metals, they make gases. Like the example I gave you: carbon dioxide, oxygen, nitrogen, chlorine. Whenever we talk about the gases, you just need to know that most of the gases we deal with them, they are colorless. So there are some general properties for the gases. Right now, I'm going to talk about how to study gases properties or behavior. First thing that you should know that in chemistry of gases, if we know three factors: pressure, volume, and temperature, we are able to find any behavior and properties of the gases. So after studying these three parameters, you are able to predict any behavior of the gases. First, I'm going to talk about the pressure. In physics, we have this basic definition for pressure. Pressure is relationship between force exerted in the area. So we have this definition: pressure is equal to force over area. In chemistry, whenever we talk about force, we are talking about force exerted by molecules, by gas molecules. So if we talk about the molecules, you are talking about small and tiny molecules. Whenever we talk about an Avogadro numbers, 6.022 times 10 to 23rd molecules, it means we talk about a large number. So if we are able to measure the force of this number, Avogadro's number of molecules, and then divide by the area that we are going to study, we call it pressure. So assume that you have the area like your laptop screen. If the molecules in our atmosphere hit with this screen, collide with this screen, and put force on this, if you are able to measure that and divide by the size of your screen, area of your screen, we call it pressure. So pressure is like this one. In chemistry, like physics or in general in sciences, we have different units for pressure. The first unit that you should know that is atmosphere. We call it a standard unit for pressure. Atmosphere we abbreviate it by ATM, and we say the number for that one is 1. 1 atmosphere is the pressure you feel, you experience at sea level. We call it like air pressure at sea level. Equal to this unit is torr, 760 torr. One Italian scientist worked on this concept, and his name was Torricelli. So that is why we abbreviated his name by TORR. So 1 atmosphere is exactly same as 760. He invented one device that worked with millimeter mercury. We call it barometer. So millimeter mercury is another unit for pressure, 760. So if you say 760 torr or 760 millimeter mercury, both are same. Both are equal to 1 atmosphere. As you see in this table, another scientist worked on this concept, Pascal, 100, 101,325. Or if we are going to report in kilopascal, we may say 101 and 101 with 325. Whenever we are going to measure the tire pressure, air in tire pressure, we use another unit. We call it PSI, pounds per square inches. So as you see here, this number is 14.7. For our class, always you are given these numbers. You don't need to memorize them. You just need to know how to apply them to solve your problem. They are conversion factors. They are going to convert one unit to another unit. Like this one, 760 millimeter mercury is same as 14.7 psi. So if you are going to solve your problem, if this conversion factor given to you, you should be able to know how to solve them. So right now I'm going to give you one example and see how in this example we are going to apply conversion factor. So let me go to the next slide. In this slide, it says a high-performance road bicycle is inflated to a total pressure of 125 psi. What is the pressure in millimeters mercury? So, question says, if we have 125 psi, what is the pressure in millimeter mercury? To solve this problem, you always start with the original quantity and unit given. So we start with 125. Then you need to convert 125 to millimeter mercury. So we are going to write psi in the denominator and 760 millimeter mercury on the top. So they are conversion factor given. So psi and psi cancel out, and then we have millimeter mercury. So if we are going to calculate that number, we have like this one. So as you see here, we are able to get the answer based on the millimeter mercury. And always I ask you to double check sig figs as well as units. So we have 3 sig figs at the beginning, so we should report as 3 sig figs at the end. Whenever we are going to review a study of properties and behavior of gases, pressure and volume and temperature should be studied together. If we study only pressure and volume, we have one law in the chemistry of gases. We call it Boyle's law. So Boyle's law just gives us relationship between the pressure and the volume of the gases. Whenever we say pressure and volume, it means we should know if we increase the pressure, what happens for volume and vice versa. So Pressure is inversely proportional to its volume. It means if pressure increases, volume decreases, and vice versa. So if we are going to write a formula for this relationship, we should say P1V1 is equal P2V2. We call this relationship Boyle's law. Boyle's law, it means relationship between pressure and volume. So 1 and 2 represent initial and final condition of gas. When we say initial and final condition, it means we are going to change pressure or volume and see what happens. In this example that you see on the slide, it says when you double the pressure on the gas, volume is cut in half. So when pressure increases, volume decreases as well. So we don't talk about temperature. That is why we don't consider temperature in our equation. In this example, we are going to review Boyle's law. As you see, here we have two information for atmosphere and volume 6 liter. So we have pressure and volume. Question says, what is the volume if the applied pressure is decreased to 1 atmosphere? Look here, it says pressure is decreased to 1 atmosphere. So it means the second pressure or final condition. We are going to find what question says what is the volume. So we are going to find and calculate the volume of the gas in the second condition, final condition. Based on the Boyle's law equation, P1V1 is equal to P2V2. So we are going to plug in the equation. Whenever you are going to solve the problems, you are going to follow the sig-fig rules as well. So the correct answer for this one is 24. Double check to make sure it makes sense or not. Here, pressure increased. Pressure from 4 atmosphere decreased to 1 atmosphere. Sorry about that. Pressure from 4 just changed to 1. Pressure decreased. Whenever pressure decreased, volume is inversely proportional to pressure. It means opposite behavior. Volume should be increased. So pressure decreased, volume should be increased. So volume just changed from 6 to 24. Another law in the chemistry is Charles' law. In the Charles' law, we have a relationship between volume and temperature. Whenever we say volume and temperature, it means we are going to study only these two, not pressure. Pressure is constant. The relationship between these two is like this statement. Pressure is not variable here and always is constant. So volume and temperature are related to each other directly. It means volume is directly proportional to temperature. It means when we increase the temperature, it means we increase the volume. If temperature decreases, it means volume decreases as well. To formulate this relationship, we may say V1 over T1 is equal P2 over V2 over T2. Again, there is no P1 and P2 because we don't talk about pressure. Pressure is constant and we don't change that. One thing I ask you to pay attention, temperature must be reported in Kelvin. If you don't report temperature in Kelvin, you cannot get any correct answer. Look at this example. It says, as the gas is heated, it expands. It means when we increase the temperature, we heat our gas. It means temperature increases. So volume increases. It means it expands. So that is why we have this relationship between temperature and volume. To solve this problem, I ask you to pause this video and answer this question. And see are you able to get the correct answer or not. Right now, I'm going to solve that. It says a sample of gas has a volume of 2.8 liter at an unknown temperature. So the volume is 2.80. An unknown temperature, we don't have any idea what is the temperature. When the sample is submerged in ice water at 0 degrees Celsius, its volume decreases to 2.57 liters. So we are changing the volume. So first volume is V1 2.80 and the second volume is final volume 2.57. The first one that we don't have any idea about that is the initial temperature T1, and we change the temperature to 0 degrees Celsius T2. Question says, what was the initial temperature in Kelvin? So there is no information regarding the pressure. So we are going to solve that relationship between V and T, because it's Charles' law. First step, you just need to convert the degrees Celsius to Kelvin. So you may say degrees Celsius plus 273.15. If you add 273.15 to 0, you should say 273.15 and followed by the decimal places. No decimal places, so we say 273. Or in general, you may add 273 because most of the temperature reported only without decimal places. When you plug in the equation and solve that, you should get 297. 297 Kelvin is initial temperature for our sample. If we are able to combine Boyle's law, relationship between pressure and volume, and Charles' law, relationship between volume and temperature, we are able to make this combined gas law. We call it P1 V1 over T1 is equal to P2 V2 over T2. So this is a general or combined gas law, relationship between all these three parameters, pressure, volume, and temperature. So you are able to derive Boyle's law and Charles' law based on this equation, or you may derive this equation based on Boyle's law and Charles' law. It depends on point of our view, and we are able to work with this. Let me give you one example. In this example, it says we have initial volume of gas 158 ml, pressure is 735 millimeter mercury, and temperature is 34 degrees Celsius. So everything reported here, we call them initial condition, V1, P1, and T1 respectively. But one thing, 34 degrees Celsius should be reported in Kelvin. If the gas is compressed to a volume of 108 ml and heated to 85 degrees Celsius, what is the final pressure? So the 108 and 85 degrees Celsius, they are final condition of volume and temperature. So whenever we are going to solve this problem, first we need to know which one is initial and which one is final condition, as you may be able to write that. This is a typo here, it should be P2. So first we need to convert 34 degrees Celsius and 85 degrees Celsius to Kelvin. I did that one at the beginning of our solution strategy. Then plug in the equation. So whenever you are going to solve this problem for P2, again this is a typo, it should be P2. So whenever you rearrange this equation, that I recommend you guys to have cross multiplication method to get the correct answer. The final answer should be have like this number. One thing, we have 3 suffix here, 3 suffix here are our temperature, they have 3 suffix, so we are going to report by 3 suffix. In this calculation, every number reported we have 3 suffix, that is why P2 should be reported 3 suffix. Another law in the chemistry of gases we should know that is ideal gas law. This term ideal should be applied whenever we are going to study our gases. We have another condition, we call it non-ideal gas law. but we don't cover this in this chapter. Ideal gas law can be reported by this equation. PV is equal nRT. Whenever we say PV is equal nRT, pressure, volume, and temperature, just three factors that we know them. N is number of moles, amount of gas, quantity, and R is a gas constant. And R always reported like this: 0.0821 atmosphere liter per mole Kelvin. You are given this equation, PV is equal to RT. Whenever we have number of moles, it means we need to use this equation. If we have no change for any volume, pressure, and temperature, it means we need to use this equation. One thing we need to keep in mind: pressure must be reported in atmosphere because the R has atmosphere unit. Volume must be reported in liter because R has liter in its unit. So again, you are given this equation, you are given the R. You just need to know how to solve the problem regarding that. So I'm going to solve one example regarding the ideal gas law. PV is equal nRT. Question says, calculate the number of moles of gas in a basketball inflated to a total pressure of 24.2 psi with a volume of 3.2 liter and 25 degrees Celsius. I ask you first, write the information. Question says, calculate the number of moles. So we are going to calculate moles, N. So N is question mark. Then it says total pressure is 24.2 psi. So pressure is 24.2 psi. Volume is 3.2 liter and temperature 25 degrees Celsius. First, we need to convert temperature to Kelvin. So right now we have temperature, volume, pressure, and also we always have R. So we just need to use PV is equal to nRT. But whenever we are going to use this equation, we need to have pressure in atmosphere. So I need to convert PSI to atmosphere. Relationship between atmosphere and PSI is like 1 atmosphere is equal to 14.7 PSI. So if you write a conversion factor like this, you will find like this number. You are in the middle of your calculation. You should keep all digits to solve your problems. At the end, we are going to report by a proper suffix around this. So PV is equal to nRT. P is this number we plug in here. V is the number given divided by R, gas constant given by problem again, and T 29.8. Right now we have multiplication and division, fewer suffix. We have 2 suffix here and 3 and more, so we just need to report by 2 suffix. This is a typical example that you may need to know how to solve your ideal gas law. Last thing for this short video that I'm going to review here is a standard condition. Whenever we talk about standard conditions, it means we are talking about some assumption and definition. They are a standard temperature and pressure. We call them by abbreviated form standard temperature and pressure, STP. So whenever we are going to talk about a standard pressure, it means we are talking about 1 atmosphere. A standard temperature is 0 degrees Celsius or 273 K. So please keep in mind, pressure, a standard pressure, 1 atmosphere. Temperature means a standard temperature. We are going to talk about this, 0 degrees Celsius or 273 K. So hope this short video helps you to solve your problems and handout and homework assignment. For last slide that I'm going to talk about this, we are going to talk about why do we need to know STP. STP, standard temperature and pressure. It says calculate the volume occupied by 1 moles of an ideal gas at STP. So N is 1 mole. When we say STP, it means standard pressure, 1 atmosphere. It means we know at 1 atmosphere. And temperature, we know that 1 standard temperature, it means 0 degrees Celsius or 273 K. R is given, so we just need to plug in it here. P, 1 atmosphere, we are going to find V in 1 mole, and R given, and T. So whenever we solve that, we will find V is equal to 22.4 liter. It means 1 mole of any gas at STP will occupy 22.4 liter. Whenever we are going to talk about this summary of the problem, we call it molar volume. It means volume of 1 mole at STP condition and STP condition. This information just reported by Avogadro's, and that is why we call it Avogadro's summary. So Avogadro's summary, it says at STP condition 1 mole of any gas will occupy 22.4 liter, and we call this 22.4 liter as molar volume. Alright guys, hope you enjoy watching this video. Take care.